So finally, we're looking at adding and subtracting algebraic fractions. Again, the rules involved with dealing with numeric fractions apply with algebraic fractions. So to add and subtract fractions, we first need to create like fractions or like terms, and we do that by writing each fraction with a common denominator. A common denominator can be easily obtained by multiplying all of the denominators together. That's not necessarily going to give the lowest common denominator, but when you're dealing with algebraic fractions, sometimes you just need to get a common denominator, get everything together as one fraction, and then look at simplifying things after that. Okay, so let's work our way through some examples. So this first one, we're looking to add, and again, much like with the multiplication and division we talked about before, if you're dealing with a fraction and something that's not written as a fraction, the first thing you obviously want to do is write both things as a fraction. So x is the same as x over 1. I'm just going to write that there. So we've got adding together two fractions. We need a common denominator. We currently have denominators of 1 and 5. So something that both 1 and 5 goes into is 5. So we want to write both fractions with a denominator of 5. The second fraction is perfectly fine as it is. The first fraction, we're going to need to multiply the denominator by 5, and so we'll also do the same to the numerator so that we maintain equivalence. The second fraction is 3x over 5. And so now we can add those two fractions together now that we've got like fractions. We've got 5x fifths plus 3x fifths. So in total we've got 8x over 5. We need to make sure that our answer is in simplest form. There are no common factors between 8 and 5, and there are also no pronumerals in common. Okay, so second example, here we have x's in the denominator, but the process is the same. We want to think about a common denominator. What's a term that both x and 2x squared go into? And in this case, our common denominator is going to be 2x squared. So we want to write both fractions over 2x squared. We don't need to change the second fraction. The first fraction, we need to think about what have we done to the denominator to turn it into 2x squared. So we've multiplied it by 2 and we've also multiplied it by x. So we also need to multiply the numerator by 2x, which is going to give us 4x. So now we have like fractions or common denominator, we can subtract the numerators. So we're going to have 4x minus 3 all over 2x squared. Again, we want to make sure that we've got an answer in simplest form. So we're looking for common factors in the numerator. There aren't any. And so everything's already factorised there, and we can't identify any common factors between the numerator and the denominator. So we're done. Okay, example 3. Okay, so again we've got nice numeric denominators here, so that makes life easy. So we want to think about common denominator first. So common denominator in this case is going to be 6. So then you want to think separately about each fraction, looking at the first fraction only. What have I done to take the denominator from 2 to 6? I've multiplied it by 3, so I must do the same thing to the numerator to maintain equivalent fractions. And in the second fraction, we've multiplied the denominator by 2, so we're going to do the same to the numerator. You can expand out as you go. I personally think there are some advantages to not expanding at all until after you've got your fraction together, particularly when we're dealing with subtraction of fractions, and we'll see that come up in the next example. So I'm going to put them together before I expand out those fractions, those brackets, sorry. So we can add together our numerators now that we have a common denominator, and then we'll look at expanding and simplifying the numerator. So we've got 3x plus 9 plus 4x minus 2 all over 6. So we have 7x plus 7 over 6. Now the numerator does have a common factor of 7, but there's no factors in common with the denominator, so that is a fraction in simplest form. You could happily leave it as 7x plus 7 all over 6, but you do want to make sure your fraction is in simplest form, so you want to think about whether the numerator or denominator can be factorised. Okay, here we have a subtraction of two fractions, and you do need to be more mindful when you are subtracting fractions, because implicit here in a algebraic fraction is that we have brackets around that. So when you're subtracting that fraction, when you've got your common denominator and you're able to put them together, you want to be careful that you're subtracting that entire numerator. So always adding in some brackets is useful. I think you can avoid or be less likely to make errors with subtraction if you hold off on expanding out your brackets, and you'll see what I mean as we go here. So our common denominator here is 6, so we don't need to do anything to the second fraction. So we're just going to have 1 minus 3x. I'm going to put those brackets around there because they're going to become important when we're ready to subtract. The first fraction, we've multiplied the denominator by 2, so I'm going to do the same to the numerator. Let's put my fractions together. So we've got 2 times 2x plus 5 minus 1 minus 3x. Now, you can see if you didn't have those brackets at that second fraction, it might be very tempting to just straight away write minus 1 minus 3x, and that's not actually correct. What you're doing here is you're subtracting all of 1 minus 3x, so you need to have minus 1 and plus 3x. So always good to hold on to those brackets. Let's just put those brackets back there. Alright, so now let's expand and simplify the numerator. So we've got 4x plus 10 minus 1 plus 3x. There's where you're likely to make the error. Collect like terms, we've got 4x plus 3x is 7x. 10 minus 1 is 9, all over 6. The numerator can't be factorised, so there can't be any common factors between the numerator and denominator, and so we are in simplest form. Okay, example 5. Now, here things start to get a little messy, but you just need to take it one step at a time and recognise that the processes are still exactly the same. So we need a common denominator here. It's not as easy to think, oh yeah, the smallest number that those two things go into is 15. But recognising that actually quite often when we're finding the lowest common denominator, all we're doing is multiplying the two denominators together. So our common denominator here is going to be a denominator of x plus 2 times x minus 3. I'm not going to bother expanding that out because I want everything factorised in algebraic fractions. It helps me to see the simplification. Okay, so then we want to think about each of our fractions. So the first fraction, we've multiplied the denominator by x minus 3. So we also need to do that to the numerator. In the second fraction, we've multiplied the denominator by x plus 2. So we also need to do that to the numerator. So now we have two fractions with common denominators, so we can subtract the numerators, again being careful about the fact that we're subtracting the entire second numerator. So we've got x minus 3 minus x plus 2. So the brackets in that around that first numerator are a bit irrelevant, but the second set of brackets are extremely important. Okay, so let's expand and simplify the numerator. So we've got x minus 3 minus x minus 2 all over x plus 2 x minus 3. The numerator tidies up quite nicely to just negative 5 over x plus 2 times x minus 3. Now again, you can expand that denominator if you want. You gain nothing by doing so and only run the risk of taking a correct answer and turning it into something incorrect. So that's perfectly fine as it is. The fraction is in simplest form. There's nothing else that we can cancel down between the numerator and the denominator, and so we're done. Okay, one more example, quite an ugly example. So what I would suggest is we could simply find a common denominator by doing those two quadratics multiplied together, much like we did in the previous one. But we might be able to simplify these fractions before we add them together, and that would make life easier. So I'd probably factorise them first and see if I can make my life just that little bit easier. So, to write a bit small here, we might run out of room. So we've got 5 minus x on the numerator there. We want to factorise this, so simple quadratic, factors of negative 3 that add up to 2, x plus 3, x minus 1, plus my second fraction again, simple quadratic, so factors of negative 4 that add up to 3, x plus 4, x minus 1. Okay, so neither of the fractions will simplify, but in having factorised, what we actually see is that there's a common factor in the two denominators. So actually the lowest common denominator, we don't need to include x minus 1 in the common denominator twice. We can just have x plus 3 times x minus 1 times x plus 4 as our common denominator. So there's no need to double up. That's a bit like when we're dealing with numeric denominators. For example, if we had, let me think, 6 and 4 as the two denominators, a common denominator would be 24, which is found by doing 6 times 4, but it's not the lowest one. And in fact, if we recognise that 6 and 4 both go into 12, we can deal with a lower common denominator, and then we don't create common factors that we have to simplify out later on. And it's the same sort of thing here. We could create a denominator that is x plus 3 times x minus 1 times x plus 4 times x minus 1, but we're only going to have things that we'll have to cancel down later. So we'll just create this common denominator. So then we want to think about each of those two fractions and what have we done to create that common denominator. So in the first fraction, we've multiplied the denominator by x plus 4, and so we need to do the same to the numerator. In that second fraction, we've multiplied the denominator by x plus 3, and so we need to do the same to the numerator. Okay, to save some space, I'm going to do two things at once here. We've got the common denominator, so we're ready to add together and put them as one fraction. I'm also going to expand out my two numerators as I do that. So my first numerator, when I expand that out, we're going to get, and I'm going to do this all at once, so we're going to have 5 times 4, which will be 20. We're going to have 5x and minus 4x, which will be plus x, and minus x times x, so minus x squared. And we're going to be adding that together. Now expanding out x minus 3x plus 3, that's a difference of 2 squares, so that's going to be x squared minus 3 squared, or x squared minus 9. Okay, so now let's collect our like terms. Those brackets that I wrote around the two separate numerators are irrelevant because we're adding. So you might just get rid of those as we go. And now we can collect like terms. So minus x squared plus x squared, they cancel out. We've just got x and then 20 minus 9, so x plus 11 over x plus 3, x minus 1, x plus 4. Again, you can expand out that denominator if you really want to expand out 3 brackets, but there's absolutely no need to do so. And we're in a position to be able to see that we've got everything factorised and that there's nothing further that will cancel down by leaving it in this form. Okay, so in summary, to add and subtract fractions, again, it's about creating a common denominator. We need like terms, so we need a common denominator. The easiest way to create the common denominator is just to multiply your two denominators together. But as we saw in that last example, if you factorise everything first, you might see that you can actually create a slightly simpler common denominator than simply multiplying them together. Take care when you're subtracting fractions to use brackets if there's more than one term in the numerator being subtracted. And there's no need to expand the brackets in your final answer. It'll help you to see whether or not you can simplify the fraction further if you leave things in a factorised form. So that's it for our brief topic on algebraic fractions. So first of all, you want to go on and complete the exercise on adding and subtracting fractions, and this exercise really does start to bring all the skills we've learnt up until now together, and can be some quite ugly expressions to deal with, but the process is always the same. Just take it one step at a time and work your way through the problems. You'll then find a review exercise with some revision, and once you've completed that revision work and you're ready to perhaps see how you're going with the topic, your teacher might be able to provide you with a test to assess how you're going at this point before you then move on to the next topic in this series of work.